Hello, it's great to be here. I will be talking about TR-069 protocol, CVMP, and software that I wrote for this. Okay. So, about me. I love Linux, I love hacking Linux, I love writing code. I especially love embedded devices, and I'm one of the OpenWRT developers. I have a question for you. Do you know what OpenWRT is? Okay, great. And do you know what TR-069 protocol is? Okay, great. So, OpenWRT, it's a Linux distribution for embedded devices. We support a bunch of different chips, bunch of different boards. It's open source project. You can build your bootloaders, toolchains, packages, whatever you find interesting with it. We are going to release soon attitude adjustment release. It's now in release candidate state. All the boards, all the targets have currently 3.3.8 kernel, and at the moment in trunk we have even upgraded to the 3.8 kernel some boards and stuff like that. What's going to change in OpenWRT is that we are going to support less packages, because it's a problem for us to support more than 2,000 packages that we have now in a repository. We are going to select only few core ones, and this will result in better support for the end users, because if you want to use Samba, this is the package you use, and that's it. If you want to play with other stuff, you will have to build it yourself. Okay, so OpenWRT gives solution and the platform for other projects to kick in and start working on some other stuff they find interesting. So, for example, we have CWMP. It's OpenWRT fork, and at the moment it deals mostly with the buffer bloat issue, which was recently, in the last few years, become known because the buffers in the routers are getting bigger, and that's why you sometimes, when they fill up, you sometimes have a laggy internet connection, and they are trying to solve it using Codel and other queue management protocols. Okay, and they also do DNSSEC and IPv6 related projects. Good thing about when you fork is that you contribute back to the original project, and this is what CWMP is doing, and it's a really good thing. CWMP, it's pretty, we might say, old protocol. It was started around 1994. Today it has around 300 members. Most of them are equipment vendors and ISPs. This talk will be about CP1 management protocol. It originates from TR-069 technical report. Let me just say, if you have any questions, you don't need to wait for the end of presentation. You can interrupt me. Okay. So let's discuss a few terms. We have CP, customer premises equipment. It's your home router, your customer's home router. CVMP is CP1 management protocol. ACS is the auto configuration server. It is the server which configures the CPE. And we have provisioning. It's process of configuration of the CPE devices. Okay. So why do we need something like CWMP? Because when you are ISP, you need to manage the devices that are in customers' premises. CPs, and how to do that when you have 10,000, 100,000, or 1 million devices. You need to have some standard. Also, if there were not a standard for this, you would end up with a different protocol from each vendor, and you would have a messy situation. And also, for ISP, it's interesting to have fine-grained access. So, for example, you want to give to your customer support employees certain access to the CP, to second-level support. You want to give even more access, and so on. So, CWMP, it's a bidirectional SOAP HTTP-based protocol. All the communication is done in XML. There are around 20 technical report schemas and data model definitions. There are a lot of parameters, I mean really a lot, and it's kind of strange to imagine to support, I don't know, a few thousand parameters on a device that has 4 megabytes and, I don't know, 16 megabytes of RAM. So what do most people do, most vendors do, they support only a few parameters that they actually need, and they don't support other stuff. Okay. So in CWMP, we have something called object and something called parameter. Object stores multiple parameters, and parameters store certain values. You can get or set these values inside the parameter. Here are a few examples from TR-181. These three down here are for configuring ACS URL and for configuring username and password for accessing this URL via HTTP. Okay, so what can we do in general with CVMP? We can reboot, factory reset, and flash new firmware. We can restore and save configuration from customer's device. So, for example, you can have a situation that customer has CP from vendor A. He configures his wireless credentials, his SSID, and then, I don't know, this device breaks, and you send him device from vendor B, another vendor, and you provision this same saved configuration to this new device, and customer won't need to configure this router again. So I think that's a nice feature that you can do. You can create or delete objects, get or set parameter values, get or set parameter attributes. But what does this actually mean? It means that you can provision credentials for PPP, SIP, and other services. You can configure services like DNS, DHCP on the CP, wireless settings, routing, firewall, and QoS, and all other things that you can read in documentation. Okay, so CP always connects to the ACS, and this is really a good thing because it makes it harder to hack it if you want to do that. It connects on various events like reboot, factory reset, periodic inform interval, or when ACS connects to the CP and tells it to connect back to the ACS. Okay, you can use HTTP or HTTPS. CP also listens for connections from the ACS, so it can connect back to. And we have object device info, in which are stored most parameters related to the CP. For example, there is stored OE, who is manufacturer, hardware version, software version, and stuff like that. Okay. ACS can configure or get status from the CPE. It can send action to provision the CP. Okay, it waits for inform messages from the CP. Inform message is the initial message in the CVMP communication, which is sent by CP. Most of the settings are in a management server object. Like you have seen before, the URL, username and password for connecting to the ACS, and also username and password for ACS when it's connecting to the CP. Okay. So, ACS, it's a box somewhere in your data center which provisions all of your customers. It has access to all of your SIP credentials for all of your users, all of your PPP credentials. Okay, so you might want to keep this box safe and not let. You want to make it hard for customers to hack it, because it would be a big problem for ISP if somebody got, I don't know, all the SIP credentials from all other users, and it's not impossible to do this, but I will cover this a bit later. Okay, so for a customer or a hacker, if he would like to see your ACS or communicate with it, he would first need to find the ACS URL, and it depends on how you have implemented it. Okay, so I have written down here two methods. First is by the book. Okay, there is DHCP option 43, which can contain the ACS URL, and you can always look into the firmware image of the CP and find the management server URL that way. Okay, and the next step that you would need to do is to connect to the ACS using, it depends again on your setup, using if it's on your separate PVC on the DSL line, you would have to set it up, or if it's on public address, then it might be a bit easier. Okay, so a quick overview of the situation when CP already connected to the ACS and it was provisioned, and the ACS wants to change some parameter on the CP. Okay, ACS then would connect to the CP. CP then would end this connection and connect back to the ACS. CP would send inform message. ACS would send inform response. CP sends empty post message. When either party sends empty message, it means that it has nothing else to say. Okay, so CP has nothing else to say. It sends empty post message. ACS replies with set parameter values. CP sets these parameters and responds with the status of this section, and that's it. ACS replies without content. Okay, so this is about theory. So about the software, first I started by writing FreeCVMP, which is client for CVMP. I wanted to use OpenWRT in production ISP environment, and so ISPs could use OpenWRT as their main system for their CPs. Okay, and then I started doing on proxy and ACS server as well. All the software is GPL version 2. That basically means you can look at the stores, make changes. You can keep those changes. You don't need to push them. You only need to push them to the other party if you are going to sell it to them. So if you want to make some changes, you can keep them for yourself. Okay, so libfreecwmp, it's a place where I keep the shared code between the projects. It's growing a bit as I find stuff that are together in other projects, and then I put it in a library. Okay, freeCVMP. It's, like I said, CVMP client. It runs on OpenWRT, and it reuses most of the user space libraries that were written for OpenWRT by other OpenWRT developers. You can run it on other systems. For example, I run it on my PC. So the freeCVMP is divided in two parts. You have freeCVMP core, which is written in C, and it basically does all the communication with ACS server. And then when ACS requests some get or set parameter or some other action, freeCVMP offloads this task to freeCVMP scripts. This is good approach for a project like OpenWRT, because that way you can only write one small script and do some feature that you want it to do. Because, for example, if you have, I don't know, asterisk as a zip client, it's not the same as if you had some other zip client, let's say OWZip that we wrote for OpenWRT, because configuration files are different. So you want to be able to just write one single script that will handle the correct placing of the zip credentials. And using architecture like this it's really easy to do that. freeCVMP scripts must be compatible with the default OpenWRT BusyBox shell, and they are modular and you can easily extend them. What I'm currently doing is that I'm reworking the way this works, because if you look at implementation for each parameter, I actually fork a new process and run shell script from the start. This takes a bit longer on a CPE device to run. So what I have been doing lately is reworking this. So we run only freeCVMP scripts when freeCVMP daemon boots freeCVMP core, and it will only listen to on a socket, and you will be much faster for you to get or set actions when you need to do that. Okay, so mod CVMP, it's Nginx proxy model for CVMP. Why Nginx? I don't know. I really like its features, and that it's pretty small and it can run really fast, and you can write models for Nginx in C, and it's kind of hard to do it, but yeah, I managed to make it work. And what you get with Nginx, you get standard Nginx features like load balancing and caching proxy. So you can have in the backend multiple ACS servers and load balance the traffic. Also, I made some, I call it protocol optimizers, features for CVMP, because it can check if the CP has sent username and password, and if it didn't, it will reply to the CP that it needs to send this stuff, and won't send this info message back to the ACS. There are few configuration options for this, but it depends on your setup, and not all will be useful for everybody. But main reason for this proxy is because in one production setup there was a security bug, and you could get credentials from other users. So what I wanted to do is actually look at the messages, and based on what's in the message, you can either reject it or approve it, or reject the message, send factory reset to the CP, or accept the message and pass it over to the ACS in the backend. Okay, for Nginx, you define approved and rejected location. When traffic is okay, it goes to this pre-configured approved location, and if something is wrong, you don't like the message, or you see somebody is doing some bad stuff, you send just factory reset to the CPE and log this so you can later analyze it. Also, I'm currently working on freeacs-ng. It's auto configuration server. I have written it as a SCGI server. If you know, you have all heard for CGI and probably FCGI, and this is basically protocol-like fast CGI, but it's much easier, and it's only one page of documentation, and it's really easy to work with it. Okay, so you have a web server which communicates with CPEs, and then this web server forwards you messages using SCGI, and then freeacs-ng parses these messages and uses AMQP, Advanced Messaging Queuing Protocol, to send these messages to some provisioning backend. What this setup enables you to do is to write simple scripts in Python, Perl, Java, or any other language that supports AMQP, and provision and to get some information and send it back to the queue. So, for example, you can end up with 50 lines of Python script, which will be able to configure SIP credentials for your CPE. Okay. Like I said, I'm still working on it. At the moment, there is only one queue, so you cannot make difference between users. All users are considered as one, but you can still play with it. What I plan to do is to define how the AMQ message will look and what format it will be. Code provisioning backend in a few languages, and I need to also code connection requester. So when you want to set some parameters and you want that CP connects to it, you need to kick it so it connects back to the ACS, and then you provision the data that you want. Okay. For more information, you can go to the Broadband Forum website, or FreeCVMP, freeacs-ng, and the libfreecwmp project websites. All the code is there, and most of the communication is done on the IRC channel. We have also a mailing list at linuxmips.org, and you can contact me if you want on luka@openwrt.org. Thank you. That's it. Any questions?
Okay, any questions for Luka?
Thanks, Luka. My name's Richard Wall. Are there any ISPs deploying OpenWRT-based equipment that are going to make use of your project?
Yes.
In the UK, or?
Not in UK, but in Europe.
Ah, okay.
You can look at Git log of FreeCVMP, and you will find out which one is that.
Ah, okay. Interesting. Thanks.
Yeah.
Thank you.
You're welcome. Welcome.
Hi, it's Tim Vey from ProView. Do you see this being like a more general TR-069 server? Because traditionally it's a very expensive piece of software. Or do you see it just being used for OpenWRT?
I'm not satisfied with the ACS servers that I've seen in production, and people are paying for this stuff, and I want to make a better one so it can really be used in production environment like ISP. So the idea is that ISP will be able to take it and put it in production when it's ready.
Thank you.
Okay.